The figure on the right is called Ochiai. Ochiai is equivalent to the unknot on the left, or they are ambient isotopic. I have two ways to prove that Ochiai is equivalent to the unknot. The first is to use a sequence of Reidemeister moves, and the second is to use p-colorability. For the first method, you can conduct an experiment by using any material that can be constructed into Ochiai, and then use a sequence of Reidemeister moves to deconstruct the knot. And the three Reidemeister moves are twist and untwist, poke and unpoke, and slide and unslide. The result is the knot on the right, or Ochiai, can eventually be reduced into the unknot, and you can try this at home. My second method is to use p-colorability. But before I introduce p-colorability, I'll introduce tricolorability. If a knot is tricolorable, then two criteria have to be followed. The first is use at least two colors, and the second is at each crossing, the arcs are either all the same color or all different. Sometimes the tricolorability is useful, but sometimes it's not. For example, consider the unknot. Well, the unknot isn't tricolorable, because I can only color the unknot one color. But the problem is we have to use at least two colors. Now, consider the trefoil. Well, the trefoil is tricolorable, since I can color this arc blue, another arc red, and since here we have one blue and one red, then this one must be yellow. Then the trefoil is tricolorable. So now we can know that the unknot and the trefoil are obviously not equivalent. But then, let's take a look at the figure-8 knot. Well, the figure-8 knot is not tricolorable. Let's try to color the figure-8 knot. If we color this arc blue and color another arc yellow, since we have blue and yellow, then this arc must be red. Since we have blue and red, this one must be yellow. But then, here we have a contradiction. So the figure-8 knot isn't tricolorable. However, the unknot also isn't equivalent to the figure-8 knot. So that's why we need to introduce p-colorability. If a knot is p-colorable, you have to use at least two labels from 0, 1, 2, all the way till p-1, where p is any prime number besides 2. And at each crossing, where arc x and y is crossing under z, then x plus y is equivalent to 2z mod p, which is the same as 2z minus x minus y is equivalent to 0 mod p. Now we need to calculate the knot determinant, or calculate p. First, number each component at each crossing like shown in the picture, and then create an n by n matrix for the knot, where n is the number of crossings. Put 2 in the column corresponding to overcrossing components, and put -1 in columns corresponding to undercrossing components, and then put 0 in columns corresponding to components not involved in a crossing. Then delete one row and one column in the matrix. Now calculate the determinant of the new matrix. I can't calculate the determinant of this matrix, so I input the data into a computer or calculator to assist me in calculating the determinant of this matrix. And the determinant of Ochiai is equal to 1, because any knot with any colorability cannot be the unknot. And since the determinant of the Ochiai is 1, it is ambient isotopy of the unknot.